So we're going to be looking at another way to count objects. A combination is an arrangement where order does not matter. So for example, if a teacher calls on 3 volunteers, it doesn't matter the order she chooses the volunteers, she still gets the same 3 people to help her out. Another thing we need to look at is the definition of 0 factorial. We're going to be seeing that later in this lesson. And 0 factorial is just defined to be 1. And I'm not going to go through the whole proof behind it. We just need 0 factorial to be 1 in order for this combination formula to work. So our first example, we're going to be taking a look at how many ways can a teacher choose 2 people to pass back papers from 5 volunteers. Again, the order she chooses these volunteers in doesn't matter because she's still going to get these same 2 people helping out. So we're going to start out with kind of listing them. So I'm going to call them volunteer 1, volunteer 2, volunteer 3, volunteer 4, and volunteer 5. So she could choose volunteers 1 and 2, which would be the same as volunteers 2 and 1. And then she could choose volunteer 1 and 3, which would be the same as volunteer 3 and 1. And there's a reason I'm writing both of them because I want to show you where this combination formula comes from. So then going on volunteer 1 and 4, volunteer 1 and 5, and then we could have volunteer 2 and 3, volunteer 2 and 4, volunteer 2 and 5, and then we've got volunteer 3 and 4, volunteer 3 and 5, and then volunteer 4 and 5, which would be the same as volunteer 5 and 4. So that gives us all of our different possibilities. So if we counted, there would be 4, 7, 10 different ways that we could choose 2 volunteers from a group of 5. So if we look through, remember the permutation formula, if we were doing a permutation of 2 people out of 5, that formula would be 5 factorial over 5 minus 2 factorial. And that would give us the 20. The permutation would be if we counted all of the ones that I wrote on the board, including the ones in parentheses. That would be where if order mattered. But we basically ended up cutting it in half, which is 2 factorial to give us a combination. So I think I've got it on the next screen. Yep, the formula for the combination is that you divide by an additional r factorial. Remember, n is the number that you are choosing from. So this is the same, they represent the same thing as they do for permutations. And then r is the number you are choosing. So however many objects you are choosing, you divide by an additional r factorial because you're cutting out that double counting where order matters. So the first thing I want to do is look at just how to use the formula. So we're going to look at the same number of objects that we looked at for the permutation. We're choosing 5 objects from a group of 12, but this time the order in which we choose the objects doesn't matter. So we start off with our 12 factorial in the numerator, we subtract them in the denominator, and then when we divide by an additional 5 factorial. So if we were to simplify this a little bit, 12 minus 5 is 7. And remember, same as with the permutation, when we expand that 12 factorial in the numerator, it will cancel with the 7 factorial in the denominator. So now I've got 12 times 11 times 10 times 9 times 8, and the rest of it canceled with this 7 factorial. But I still have my 5 factorial now, which is 5 times 4 times 3 times 2 times 1, of course. And you can simplify this. So for example, 4 times 3 equals 12, so we can cancel that with the 12. And 5 times 2 equals 10, so we can cancel that with the 10, leaving us with 11 times 9 times 8, which is 792, which is a lot fewer than the 95,040 we saw with permutations. All right, so the last slide for today is differentiating between permutations and combinations. So if you are arranging 5 posters on your wall, I want you to think for a minute, will the order you hang those posters matter or not? So would it be a permutation or a combination? Hopefully you came up with a permutation, because if you have poster 1 here and then poster 2 and so on, it would look differently than if you started with poster 3 and then poster 2 and poster 5 and so on. So this is an arrangement where order matters. So then we're going to evaluate. We have 5 posters that we are choosing from. We decided it was a permutation, and we're going to hang all 5 of them. So this is a 5p5. We're choosing every object in our group. So we get 5 factorial over 5 minus 5 factorial. So we get 5 factorial over 0 factorial. And this is where our definition of 0 factorial comes in. 0 factorial is 1. So we end up with 5 factorial, which is 120. So there's 120 different arrangements of the posters for our wall. So part B, if your teacher is asking you to choose 3 of 6 books to write a report on, would that be a permutation? Does it matter the order you choose the books? Or a combination where it does not matter? Okay, so I hope you came up with a combination. Doesn't matter the order you choose the books, you're still writing a report on the same 3 books. So we are choosing from 6 books. Order does not matter, and we're going to write a report on 3 of them. So we start off the formula the same way we start off the permutation formula, but we divide by an additional r factorial, or number of objects that we are choosing factorial. So we start to simplify this a little bit. Remember, everything 3 and below will cancel with one of my 3 factorials, so I end up with 6 times 5 times 4, expanding one of my 3 factorials, the one that didn't cancel, and we end up with 3 times 2 equals 6, so those would cancel, and 5 times 4 gives us 20.